Here's the question then, the picture. Region R. Here's the trapezium problem. Part A. Which is part B. And then part C and part D. Okay, I've got it all summarized here. Let's have a look at it then. Complete the table first of all for part A. Here's the function, here's the x value. So it's 10 divided by bracket 2 times x, which is 3, plus 5 times the root of x, which is 3. Outside bracket, press the and get the decimal. 68211, 0 point, which seems to fit. So use the trapezium rule. So I'll call it the integral as approximately equal to then h over 2. The first plus the last, plus 2 times all the ones in between. So that would be y4, wouldn't it? H is b minus a over n. B is 4, a is 1, n number of intervals is 3, so h is 1. So you end up with a half, 1 over 2. The first plus the last, 42857. Plus the last, plus 2 times the ones in between. Oh, it's just, oh, this is y3, sorry. There's 4 ordinates. And this is y2, there's no y3. Got too many ordinates there. Okay, 2 times these two. Close brace at the end. Tap that in the calculator and see what we get. So let's have a look. So it's 0.5 times brace, 1.42857 plus close the bracket, close the brace. 2.577435. But we needed a 4dp. Yeah, 4dp is here, so it's just 4. Okay, that's part B. C is an over and under estimate. If we look at the curve and we draw the trapeziums, we're going to see, because it's a concave curve. So C is an overestimate. Trapeziums lie above curve, above the curve. Probably better English, isn't it? D. Okay, let's find this integral. So du dx we need. This is x to the half. So du dx would be a half x to the minus a half. So du is equal to x to the minus a half dx. So let's see what we get here then. So I is equal to then integral between 1 and 4, 10 over. Now I'm going to take a root x outside, And I'm going to be left with 2 root x here plus 5. If you think about it, take a root x out, and the dx over root 2 then, root x rather, will be this part here. It's between 1 and 4. So it's 10 over 2u plus 5, isn't it, with the substitution? Dx over root x is just du. When x is 1, u is equal to root x, wasn't it? So u will be 1. And then when x is 4, u is 2. There we are. Let's do those two values. So we've got, it's going to be the natural logarithm of 2u plus 5. Log of something goes to 1 over something multiplied by the something differentiated, which is 2. We've got 10. So we need a 5. So we get 5 ln, put 2 in, 9, minus 5 ln, put 1 in, 7. So it's going to be 5 ln 9 over 7. And that's the exact answer, isn't it? Which I think the question asks for. Okay, just a couple of changes here. I've just looked at the solution, and I've noticed the stupid error here. That should be a 7, shouldn't it? But there's one other silly error, because I think I was rushing part D a bit. That's my excuse, anyway. Is the 2. I've got the 2 here. So take the 2 up to be with the du here. So we've got 2 du is that. So this can be replaced by 2 lots of. And that would end up being 10 in here, wouldn't it? Instead of 5. And that'll be 10 and 10 and 10. So let's just make that change. It's a good idea when you do the paper to double check. Always double check at the end of the paper, time permitting. And then if more time permits, do a triple check.